problem 1392 longest happy prefix. So for this problem, we are giving a string, and this string is called happy prefix. So if it is a non-empty prefix with some sort of suffix excluding itself, so it should exclude itself. So for example, this AA prefix suffix, but we need to exclude itself. Yeah. So this AA is not a happy prefix, because we need to exclude itself. So if it is set like that, basically this is a KMP algorithm. So let's just check the first example. Yeah. So for the first example, if this is a level, the first step is that we're gonna prepare a next table. So this is gonna be next table. Yeah. Now we have this these characters like from the L, E, and the next one will be V, and the next one will be E, and the last one will be L. Yeah. And the next step is that we just need to, just to fill in this next table. Yeah. So this is L. If we are going to use the KMP algorithm, for the first one it is a 0, right? And now we are going to check the prefix and the suffix, because this is for building the next array. Yeah. And this is just E. And now we want to find the L. This is the L, so this means it's going to be a 1 for the next table. So if you are not familiar with the KMP, so please check the videos about the KMP algorithm. Basically, you need to know at least what is a KMP algorithm. Otherwise, you don't understand what I'm talking about. Yeah. So for others, this is E. So for the next table, it's going to be 0, and this way it's going to be 0, and for this E, it's going to be 0 as well. Yeah. Currently, this is 1. So for the last character, this is 1. We are actually going to find the prefix and the suffix, and for this last character, it is 1. It means we just need to take the first character, it's going to be L. Because this is 1, so we just need to take L. So let's just use a next example. So the next example, it is much longer, so it's going to be something like AB, AB, and AB. Yeah. So what's going to happen for this array? So currently this is a 0, okay, and this is a 0, and now as this is repeated, right? Yeah, because this is the prefix and the suffix. So for this is the prefix is A and suffix is A, so it's going to be a 1. So the prefix is AB and the suffix is AB, so it's going to be a 2. So the prefix is ABA and the suffix is ABA, so this one going to be 3. So the prefix is ABAB and the suffix is ABAB, they are equal, so this is going to be a 4. Yeah, so this means our final result is going to be ABAB, because the index is 4, it means there are going to be 4 characters. Yeah, so basically it's going to be something like 3s to 4, so this is going to be the final result, it's going to be ABAB. Yeah, now the problem becomes, how can we calculate this next table? So this is the most important part about KMP algorithm. Basically, we need to calculate this kind of next table, and then we can use this kind of next table to solve any kind of a string matching problem. Yeah. I'm not gonna yeah, so here I'm gonna use a very simple way of calculating the next table, and everything is just about KMP algorithm about how to calculate the next table. So I'm gonna define a function for calculating the next table. Inside it's going to be this string s. So for example, this is my string, and I'm going to use this string as my pattern to calculate the next table. So I'm going to prepare next array and string. So next array, I'm going to design it. For the first place, it's going to be a -1. This means it's just a dummy place, and most people are going to use this kind of a -1 as the dummy place for calculating. And this is index j gonna be a -1 as well. Now, as this I is basically for this string or for this pattern, and there's no backward for this I. So basically, this I gonna just go forward of length s, and now this j can go backward. So this j is going to be more than or equal to 0, and we're going to check the pattern. If sj, si not equal to sj, yeah, it means they are not equal. If they are not equal, what are we going to do? We're going to use this next array, otherwise it's going to be a brute force. So j is going to be jumped to next j, and after that they're going to plus equal to 1, and the next array going to append this j. Finally, we're going to return this next array. So this is just for calculating the next array. Currently, we can use currently we're gonna find the index. We're gonna find what gonna be the number for the last index. Yeah, so it's gonna be a k. K gonna be equal to the next array of this pattern, and it's gonna be the last character because this is an array. It's gonna be the last number, so it's gonna be a -1. And finally, we just need to return string with this k. Yeah, so this is everything just about KMP, and this is just a next array. We are not calculating the string matching yet, but this is enough to solve the problem, because we are just need to find the happy prefix. It means the prefix equal to the suffix. Yeah. If return an empty string if it does not exist. Yeah, so if it does not exist, what's gonna happen is for this k, this is 0, so as 0 to 0, it's gonna be empty. So we don't need to change anything about this case. Yeah, and we should also be careful about it should be excluding itself. Otherwise, we have to do a stencil check. Because if excluding itself, basically we can directly use the KMP to solve the problem. Now let me just run it to have a check and submit it. Yeah, now as you can see, it works and it's really fast. It's like 100% because KMP is the best and the fastest algorithm for string matching problem. Thank you for watching. See you next time.